This video serves as a revision video for people that are studying the IBAI standard level program. If you are looking to revise your hypothesis testing and a little bit of the descriptive statistics, this video will be very helpful. The first question says, at the end of a school day, the headmaster conducted a survey asking students in how many classes they had used the internet. The data shown in the following table. The data is shown in the following table. It says, state whether the data is discrete or continuous. The data that we're talking about, what was collected, was the number of classes that they had used the internet in, and that can only be measured using countable numbers. As a result, that is discrete. The mean number of classes in which a student used the internet is 2. Find the value of K. For this type of data, this is how you find the mean. You add up all the values times their frequency, and then you divide that by the total frequency. So you divide that by the total frequency. So that means we're going to do 0 times its frequency, add 1 times its frequency, and 2 times its frequency. And then 3 times k is 3k, 4 times its frequency, 5 times 3, add 6 times 1. And then divide all of that by the total frequency, which you get by adding up 20, 24, 30, k, 10, 3, and 1. And the question tells us that this mean is actually equal to 2. So on your calculator, I think I need to delete all of these. Okay. We're going to add up all the frequency times their values. As you will see, I'm going to skip 3k here because it's a variable term. We cannot add it with the non-variable terms. We can only add like terms. So that should be times 3, 6 times 1. So that gives us 145 for the non-variable terms. And then we add the variable term. We also have to add the frequencies. And again, we are going to have to skip k because k is a variable. Right now, we're not adding variables. So that would be 88 plus k. Then we're going to solve this equation. On your calculator, you're going to do 2 equals, use a fraction here, 145 add 3. I'm going to use x in the place of k only because that is the typical variable that we normally see. That's supposed to be plus. There we go. That tells us that k is equal to 31. So you just use solve on your GDC. It was not possible to ask every person in the school, so the headmaster arranged the students' names in alphabetical order and then asked every 10th person on the list, identify the sampling technique used. This is systematic sampling. Next question says, university students were surveyed and asked how many hours they worked each month. The results are shown in the table. use the table to find the following values. Remember how we work out cumulative frequency. We say 3 add 7, you get 10. Then we do 10 add 10, we get 20. Then we do 20 add 14, it gives you 34. 34 add P gave you 44, right? 34 add P gives you 44. So you can use solve to solve this. It's not really necessary. You can also just do 44, take away 34. But here we go. X equals 44. Answer's 10. Next question says, find Q. So like I said, you do 44 add 6 to get 50. You do 50 add 4 to get 54. So you're going to do 54 add 2 to get Q. So Q is equal to 54 add 2, and that just means Q is 56. Next question says, each month the number of days of rain in Cardiff is recorded. The following data was collected over a period of 10 months. And that's the data. For these data, the median number of days of rain per month is 10. So when you're finding the median, you have to arrange your numbers in order. So let's do that first. 7, 8, 8, 8. And there's 2 11ths. Then there's 13, 14, and 15. Okay, now we need to figure out where to place X. What you need to remember is how you find the median for an even data set is different from how you find the median for an odd data set. If you have an odd data set, like an odd number of values, let's say you have 7 of them. So it kind of looks like this. 1, 2, 3, 4, 6, 7. Then the median would just be the middle one, right? But if you have an even data set, so let's say you have 8 numbers, 1, 2, 3, 4, 5, 6, 7, 8 numbers. The median would then be the average of these 2 that you have in the middle. So you add those 2 together and you divide them by 2. That's how you find their average, right? We have an even data set. There are 10 months, so we have 10 values. So we need to figure out where we're going to place X if the median is supposed to be 10. When you look at these numbers, if I said that the median was here, then that means I'm doing 11 add 11 divided by 2, and that would just be 11. But that's not the median. The question says the median is 10. So that means we have to place X before 11. Here, that's where X goes. Then the median would be the average of X and 11. And then we have to divide that by 2, and that has to give us 10. So let's solve for that. 10 is equal to X plus 11 divided by 2. Oops. Nine. Okay, then it says find the standard deviation. So on your calculator, you're going to input all these numbers that you were given on a list. So you're going to do list 1 as an input. So let's go to the menu. You find your lists on statistics. I have several lists, so I'm just going to delete those. See. I think I can just do that. Okay. Okay, I need to make a list with all the numbers that we just found. We say the numbers were 7. Oops, that's not here, that's here. 7, 8, 8, 8, 9, 11, 11, 13, 14, 15. Those are the numbers. And after that, we're going to do a calculation. So you go to stats on your calculator. It depends on which graphing calculator you're using. I'm demonstrating using the Casio, but it works the same way. If you go to statistics and you look for the calculations and you look for one variable statistics, then you will be able to find the standard deviation. It will be written with this symbol, and that's 2.69. Okay, then it says find the interquartile range. So I'm going to write the numbers that we had again. Okay, the median, like we said, was between 9 and 11. The median was the number 10. And so then when you're looking for your interquartile range, you need to subtract your upper quartile, take away the lower quartile. How do you find your upper quartile? It's the median of all the numbers that are greater than the median. So when you look at all these numbers, their middle number is 13. That is your upper quartile. That is Q3. Then the lower quartile is the median of all the numbers that are less than your median. So that's this one. That's your lower quartile. And that gives you a 13, take away 8, and that's a 5. That's the interquartile range. Okay. Next question says, as part of a study into healthy lifestyles, Jing visited Surrey Hills University. Jing recorded a person's position in the university and how frequently they ate a salad. Results are shown in the table. Jing conducted a chi-squared test for independence at a 5% level of significance. State the null hypothesis. This is a test for independence, which means that the initial assumption was about independence. It was that the number of salad meals a person eats a week, the number of salad meals per week is independent of a person's position in the university. Okay, let's go to the next question. 4B says calculate the p-value for this test. The data that we were given in this test was in the form of a table, a two-way table. So in order to capture this data, we're going to have to use a matrix. So what you would do is you go to your run matrix or your normal calculator page. There's going to be an option for MAT, VCT, vectors, matrices. That's the option that you pick. And this is a 3x4 matrix. So that's what we're going to do. And then it will give you empty boxes here that you have to fill in. Right? As you've seen here, that's what's done there. I'll start that process again. Let me just delete this. Okay, you go to your run matrix, your normal calculator page, and you look for MAT, and then that's where you're going to input The number of rows is 3. The number of columns is 4. And that's going to create a 3x4 matrix for you. And then you're going to input all the data in this that's on the table in this matrix. Okay, then you go back to the menu and go to statistics now and go to test. We're trying to do a chi-square test, and this is for a two-way table. And already they've captured the matrix that we put our information in, and you execute. That tells you the p-value. So p is 0.02011. State giving a reason. Let me just write the instructions there again. Step number 1 was to input your data as a matrix, right? However, your calculator inputs matrices. And then step number 2 is to go to statistics and do a chi-squared two-way test. So you go to the tests, hypothesis testing, and then you go to chi-squared, and then you do a two-way test. That's it, and that's how you get that p-value. State giving a reason whether the null hypothesis should be accepted. We're going to use the significance level and the p-value. The p-value is 0.02011, and that's less than 0.055%, which was the significance level. And so as a result, we're going to reject the null hypothesis. 5% is the significance level. That means that that is the highest possible number we will tolerate if we're to accept a hypothesis. Anything lower than that is not tolerable, and we reject the hypothesis. Anita is concerned that the construction of a new factory will have an adverse effect on the fish in a nearby lake. Before construction begins, she catches fish at random, records their weights, and returns them to the lake. After the construction is finished, she collects a second random sample of weights of fish from the lake. Her data is shown in the table. So this first data set we're going to call X1, and this second data set we're going to call X2. Anita decides to use a t-test at the 5% significance level to determine the mean weight, to determine if the mean weight of the fish changed after construction of the factory. State an assumption that Anita is making in order to use a t-test. There are two assumptions that help you use a t-test. Firstly, it's that the data is normally distributed, as in it follows a normal distribution. The second assumption is that the variance, which is the one I will write here, the variance of the two data sets is equal. And the hypothesis for any t-test is, you see that it says they want to determine if the mean weight. So the discussion here is about the mean weight. We want to see, is the mean weight going to be more than or stay the same or less than, or is it like, does it have any change at all? So the initial assumption is that there is no difference, that the mean of the first data set is going to be equal to the mean of the second data set. And then the alternative hypothesis is that it's going to be different. In some questions that use the t-test, they specifically say the weight is going to be more after construction, or they'll say the weight is going to be less after the construction. But in this question, she didn't say that. It just says there's an effect. We don't know if it's going to be less or more, and that's why we're just writing not the same, right? And this is really important. What you choose to write here is really important because you do put that in the calculator. It's deciding whether your test is one-tailed or two-tailed, right? Right now, our test is two-tailed. If it had said less than, we were going to have a one-tailed test. If it had said more than, we would have a one-tailed test. But because it just said it's going to be different, not the same, that's a two-tailed test. Says find the p-value for this test. Okay. For this test, how you put your input is you just use the lists. So you're going to have list 1 and list 2. Okay, going back to the menu, going back to statistics. And I'm going to change this list. So now it's 2.7, 3.2, 4.1, 3.5, 2.6, 3.7, and 2.8. Then the second list, oops, shouldn't have those here. Second list goes 3.2, 1.9, 4.2, 2.5, 2.9, 2.6, 8.2, 3.8, and 2.1. Then we go to tests. Again, statistics tests. This time we're doing a t-test. And it's a two-sample test. We have the sample we got before the construction and after the construction. So again, you go to statistics, you go to the tests or hypothesis testing, depending on your calculator. You look for the t-test, you look for the two-sample t-test. And just remember to always adjust this part of your test where it says mu1 is not equal to mu2, because sometimes you're allowed to put a greater than sign or a less than sign. So just make sure you pick the right thing there. Okay, now we can do the test, and it tells us that the p-value is 0.3861. State the conclusion of this test. So again, the p-value is 0.3861, and that is greater than 0.05. So it's above our tolerance, which means we can tolerate this and accept the null hypothesis. Okay.